Okay, hello everyone. My live broadcast didn't quite go to plan, I don't think. Not sure, I'll have to check later if it all got recorded. But here is what I did online, although it might not have got through. So welcome, another live astronomy broadcast from the WIllingdon Observatory. This is mainly for EAS members using some of the society gear. This is the second lockdown live astronomy broadcast I've done. The first one a couple of days ago, I had a couple of technical problems, but I seem to have got past them now. I had to reinstall some software. Anyhow, here we are. That's me on my observatory, and as you can see, it's dark, and I've got some red lights because red lights are useful for astronomy because they don't destroy your night vision. So the gear I'm using, here it is in night. The long one is a refractor with a camera on that, and the shorter one is a soft Cassegrain with a DSLR on the end of that. I'll put it in a daytime picture instead, you can see a bit better. The long one is a refractor, it's a 127mm triplet apo. We have an ATIK Infinity camera connected. There's no wires on it in this picture because it was whilst I was setting it up. And mounted on top of that telescope, you can see a smaller telescope, which is my autoguide scope. It's a Orion mini guide scope, and it's an Orion Starshoot autoguider camera. The other scope has got a DSLR on it, but I'm not using that for this event. There's no wires because I was setting it up. Okay, the ATIK camera, the red thing, comes with its own software that allows you to stack images on the fly. Astro imaging is a skill and an art where you generally take lots of images of the same thing and you stack them to get rid of some of the noise in the pictures. You generally do that. You take many pictures over an evening, and then the day after or later that night you use the software and stack the images and do a few other things. With this cameras and the software, it's built to do it on the fly, so you can do it live. Okay, it's not quite as good as doing it the other way, but it comes out with an acceptable result. So anyway, to start with, I've already set the telescope up to look at M13. This is the object we looked at the first time, but I didn't get this bit of software running. This is the Infinity software here, running in Windows. I run a Macintosh. So you can see we have M13, the Messier 13. It's the Great Globular Cluster in Hercules. Messier, I think it was in the 1700s, 1800s. He was a person interested in spotting comets. So he made a big list of items that he didn't want to see, which we now call the Messier list. There's 110 of them. This one's Messier 13. Just two types. It's a star cluster. Those are all stars. Globular clusters are some of the oldest objects in the galaxy. They've been around a long time, much longer than the Earth. I mean, the Earth's about 4 billion years old. Globular clusters are generally nearly as old as the universe, so you might be talking 10, 11 billion years old. There's another type of star cluster called an Orphan Cluster, which of course is stars are just open, they're just randomly arranged, whereas you can see from these these look gravitationally organised. You could talk like a mini galaxy, but it isn't. It's just a few thousand or tens of thousands of stars. Like I said, these are some of the oldest stars around. Stars have colours depending on how hot they are. You can have red stars, orange stars, yellow stars, like our sun. You can have blue stars and white stars. It's also with the temperature. Generally you'll find that orange stars last a long time. So generally the brighter the star, the faster it burns its fuel, which is hydrogen and helium, and the faster it burns out. So some stars may only last a few million years, but of course our stars already lasted 4 billion years. And I think it will last another 4 billion years before it turns into a red giant. So I think we're okay at the moment. Now this is just a single image. Oh, sorry, I tell a lie. It is only it is only a single image of 10 seconds, and it's not stacked because I've not selected the option yet. So if I now start selecting the option, you get noise in the background. There's a little pixels being on and off. If we start stacking, what should happen is, because that's random, noise is random, it isn't always in the same place on every image. So basically it starts disappearing. So you saw then the background went much darker. And that's because with stacking processes going now, which makes the image better. The stars show up better, the background disappears, it goes darker. You can do more things to the processing, and that's one of the arts of astro imaging, how you actually change the image afterwards. So these are all. This is a star cluster, a globular star cluster. It's in our galaxy. It's in the constellation of Hercules. It's called M13. And you see the picture's actually quite nice. All the stars look yellow. It's interesting. I said about stars having colour. Depends on how good your equipment is, how well it shows it, and how well you process it. I've never been very good so far at processing colour into stars, and this software isn't doing brilliant either, because they're all yellow. But I do know that when we look at the Orion Nebula through this, we can't at the moment because it's too low in the sky and out of view. And that does show up purples and blues, so there is definitely colour coming through. It is a colour camera. You can buy mono cameras which just do black and white, and you have to use filters then to actually get colour images from them. Well, this is called one-shot colour, and as you can see, it's a colour image. And that's quite a nice image. Now what I'll do while I'm here is I'll save it, simply because I can, for another time. So that's M13 JPEG. Okay, save that. M13 already exists. Oh, okay. Replace it. We'll say yes. Okay. Okay, so there's M13. Right, so what we can do now, we can move to another object. So I go back to software. So use the software now. Mount control. So if I M64 was the object I wanted to look at next. So let's just change this and put in M64. Okay, that. Go to. So the telescope's moving again. I have to duck around it. I've only got a small observatory. I have to move my dome myself. I've got a proper dome. But it isn't motorised. It's motorised by me. So let's just move it. It needs some oiling, doesn't it? Okay, so now then let's go back to our plate solving software. What plate solving does is it takes a picture of the sky, works out what it's actually looking at by using a database of stars, and then more accurately aligns your telescope. So the image shown here at the moment is the image that I used to align it on M13. So that's M13 in the middle there. As you can just see, the image has just changed. And I'm guessing that that might be M64 in the middle there. So let's just see what it's doing. So now it's wasn't quite accurate enough, so it's just taking another image and it'll move itself a little bit further. Okay, so now it's an acceptable accuracy. Let's go back to the camera. We'll reset the image. And hopefully now you'll see something different in a minute, or in a few seconds. Yes, here we are. So now we're looking at M64, which is called the Black Eye Galaxy. This is in a constellation called Coma Berenices. There are 3 constellations close to each other: Coma Berenices, Leo, and Virgo. And between them they have lots of galaxies in them. And this is just one of the many galaxies there. So it's called the Black Eye Galaxy. A lot of things have got names, been given names that may represent them. Like, of course, we talk about the constellation of the Great Bear and the Plough. The Plough isn't a constellation. The Plough is called an asterism because it's not the whole constellation. So things are given names. Most of the constellations were named hundreds or thousands of years ago. Things like galaxies, of course, are relatively recently found, so they're given sometimes more modern names. In fact, I've seen one called the Vacuum Galaxy. Anyway, this is the Black Eye Galaxy, presumably associated with the black eye. As you can see, it's quite a nice shape. You can see different features in the galaxy. It's not quite a head-on view, and it's not an edge-on view. If it's edge-on, it would be a very thin slither. If it was face-on, it would be a big round disk. There are different types of galaxies. The Milky Way is a spiral galaxy, so it's got spiral arms. There are galaxies that don't have spiral arms. There are galaxies that are more like amorphous blobs. Normally they're giant galaxies, those. Elliptical galaxies they're called. And quite often they're formed by many galaxies merging. It looks like the vast majority of galaxies that haven't had any interaction are generally spiral type galaxies. As galaxies interact, like M51 is a famous image that has 2 galaxies that are actually interacting, of course very slowly from our point of view. When galaxies merge, stars don't actually hit each other because there's so much space, but the gravity affects everything. Okay, so this is the Black Eye Galaxy. And it's quite a nice image again, this. So we're doing 10-second images, so we're not doing long exposures. You can do 10, 15 minutes exposures. Exposures are limited by how good your gear is, your telescope gear is, because if your telescope gear isn't very good, then stars will start trailing, because that's what would happen. The shorter exposure, the less trailing there is. 10-second exposure, you shouldn't really see any trailing. I've not got any auto guiding set on because there's such a short exposure. So stars are still particularly quite round. Again, this is a nice image. It's not an edge-on galaxy. It's not a face-on galaxy. It's inclined. In the centre of the galaxy, there's many more stars, so it's much brighter. As you go farther out from the galaxy, you get less and less stars, so you don't see as much detail. Same with our galaxy. Our galaxy's got a lot more stars in the centre of it. And if you look towards the centre of the galaxy, the Milky Way, when you look at the Milky Way at night, unfortunately the Milky Way, the centre of the galaxy is always very low down in our sky. So it's always hard to see the centre of the galaxy, but that's in Sagittarius, our constellation of Sagittarius. And there are a lot more stars there. If you look the opposite direction, of course, you're looking out from the galaxy, so you see less stars. One thing here is, when you see pictures of galaxies, all these dots here, if they're dots, are all stars. You can't see stars in galaxies, in other galaxies, because they are just too far away. Okay, so that's another nice image that's been stacking for a short while. That's only 250 seconds. This is M64. I want to save this image for posterity. M64. Let's save that. saved. Okay, so that's M65. Now the next one I'm going to do was M65. So this is in Coma Berenices, if I can pronounce it correctly. So what we'll do now, we'll move to a different, move the scope again. So we'll go back here. We'll go to, oops, yeah, click the right buttons. I want to go to M65 now. M65, so here we are. Okay, that, do a go to, going all the way around. What's called a Meridian Flip. Once it passes the southern meridian, the scope quite often swaps all the way around on its mount. So that way it can track it for longer. So what we'll do, we're ready for when it stops. I need to move my dome again so it can see through the slot, the shutter. I think that should be okay. So let's just take a plate solving to get it in exactly the right place. Once again, that's the image from the last plate solving exercise. Should change in a few seconds. Yeah, I know it changed. So now it will solve what it's looking at, move slightly to be more accurate. I'm guessing that there might actually be what we're aiming for, so it'll move, it should appear in the middle next time. I'm running all of this software on the window here on a Raspberry Pi. Oh, that must be it there then. As opposed to my laptop. Here we are. That'll be it there. Not quite reached the required accuracy, so it's doing another step. It's got it there now. It's gone green here, so I know it's reached the required accuracy. So it must be in the middle there somewhere. I can't really see it very well. So let's go back to our software. That's from the previous one. That's M64. So we stop stacking. And reset the picture. There we are. Great. So this now is M65. So M65 is one of the Leo Triplet galaxies. This is a bit more edge-on than the previous one. You see it's more like getting more line-like. Again though, you've got a central region of the galaxy, which is a lot brighter because there's many more stars there. As you get further out, it gets fainter. Once again, these are all stars in our local galaxy, the Milky Way. Stars in that galaxy are too far away for us to see, so they appear as a mistiness. I mean, even Hubble can't really make out stars in other galaxies. They are just so far away. like I say, galaxies far, far away. The closest galaxy to us is the Andromeda Galaxy. Our galaxy is about 100,000 light years across. 100,000. The Andromeda Galaxy is 2.5 million light years away, and that's the closest to us. These other galaxies here now are all much further. I could look up in a planetarium program to figure out how far they are, but I don't actually know offhand. But these are in Leo. So while it's stacking, if we just look at a planetarium program, let's just have a quick look. If I go to, see, so there's the Black Eye Galaxy. The Black Eye Galaxy was 24 million light years away. And we zoom in here. We're on M65 now. That's M65. M65 is, well, it's not telling me how far away it is. It's not very nice of it. Let's try again, see if it tells me. No, it's not telling me M66. It tells me M66 is 35 million light years away. So I'm guessing that M65 is something similar. So these are more than 10 times as far away as the Andromeda Galaxy. An interesting point there, because they're 10 times further away, they'll appear about 10 times smaller, assuming they're about the same size. So we go back here. So the Andromeda Galaxy would be about 10 times the size of this. So there's no way it would fit in the frame of this camera. So the Andromeda Galaxy is actually quite a large object to view in the sky. That's one reason I'm not looking at Andromeda Galaxy, because it wouldn't fit. It's too big. Yeah. So here we are. So this is M65 in Leo, one of the Leo triplet galaxies. It's called Leo triplet because quite often in cameras you can see all three galaxies at the same time, depending on your view. So that's been stacking for not for long, only for 3 minutes. Now the longer images you take, generally the better the images are. But the whole point of this is to see things quickly. Rather than get Hubble quality pictures, we get less quality, but we see something. That's a really great thing about it. So that's M65. So let's take a quick picture of that. M65. Capitalize it. M65. Save that. Okay, save that. So the next thing I said was M66. So let's go back to our telescope software again. Now M65 and M66 are quite close together, but of course they won't fit in my field of view with this camera. So the telescope will move slightly. Okay, only move slightly. We'll still do plate solving again. If you have your telescope very well aligned, then you might not need to do plate solving to find objects, but I find it just makes it easier. So it's loaded a new picture. Now it's running the solver. It's actually even running the solving on the Raspberry Pi, so it's doing okay. That was close, but not on the dot. So now we've got a green mark. It took 10 seconds to solve that on the Raspberry Pi. So we go back to our imaging software again. Now that's the last one. So let's stop stacking, reset the image. I think I'll reset again because it might be mixed. So here we are. So this now is M66. So this is close to M65 in Leo. Of course, in fact, you can probably, that might actually be M65 there, the edge of it. So it's quite possible we could see them both at the same time. So here we are. So these M66. This is a slightly different shape again. It looks a bit more warped. It looks like there's like an S sort of shape to it as well. So I'm guessing this is either a spiral galaxy or a galaxy that has had some interaction with other galaxies at some point in the past, which would change its shape. So we're stacking images here at 10-second images still, not long exposures. Again, all these dots here are stars in our galaxy, the Milky Way. I think we just looked a minute ago, this was 35 million light years away. So when the light set off from that, it was 35 million years ago. Not quite when the dinosaurs ruled the Earth. Presumably there were some small mammals around on the Earth at that point in time. Oh, sorry, I forgot to click stacking, didn't I? Oh, dear me. Right, we're now stacking images. So now the image should improve. There we are, the background went darker. Just let it run for a few more images. Yes, and I think that's definitely M65 on the left-hand side of the screen of the image. Okay, you can see it's looks like it's got two spiral arms at least, that sort of shape and that sort of shape. Again, as the live streaming didn't seem to work, this is a recorded version, and so I'm getting through things slightly quicker. Now I'll save this image. We're on M66. So let's put M66. So that image is saved. Posterity. Okay, the next thing to look at that I looked at earlier was something called the EAS, which I believe is NGC 4438, if I remember correctly. So let's have a quick look at, see if we can find it. So we want NGC 4438. There we are. Okay, let's undo and go to. So far we looked at Messier objects. Like the Charles Messier guy. He didn't spot everything, of course. There's lots of different catalogues. Oh, it's going all the way around again. Of objects in the night sky. NGC is the new galaxy catalogue. We've heard of Herschel, John and William Herschel. Some of those people have created catalogues of objects in the universe. And of course there's even the Patrick Moore catalogue, the Caldwell catalogue. It's coming close to me again, the scope. I've got to squeeze in a bit. There we are. So the EAS is again another galaxy in the same part of the sky. Within the, I think it's in Virgo. Let's have a quick plate solve. But it isn't a Messier catalogue item. I said he only listed 110 objects. Of course, he didn't know at the time that galaxies were actually galaxies far, far away. They just, quite often they called them planetary nebula. They thought they were all within our Milky Way and thought ours was the only galaxy there was. Of course, we know different now. So now we're looking for an object called NGC 4438, which its known as name is the EAS. So we go, while it's doing that, we go to the planetarium program I've been using. I think we come over here. Somewhere in here we find the EAS. So the EAS are part of the Macarian chain of galaxies, which is too big for me to show in the frame. We've got a distance here, so these are 47 million light years away. So they're going further away again. So of course, as we go further away, they'll appear smaller. Let's go back to here. So we've got green, we're aligned. Go to our software, turn off stacking, do a reset. So here we are now. So now we'll turn stacking on. So here we are. So these are, or this is NGC 4438, and it's actually two galaxies, and they're called the EAS because somebody's decided they look like a pair of eyes. So once again, like I said, these are further away again, so they're smaller objects to see, smaller and fainter. So we won't see as much detail as on the previous objects, simply because they're smaller and fainter. The two galaxies again. Once again, all these other dots here are stars in our own galaxy. If you do deep enough images, you start seeing other galaxies. By deeper, I mean longer exposures. I mean, we all know about the Hubble deep field and ultra deep field images, which show thousands and thousands of galaxies. So everywhere you look, there would be galaxies in the background if you had a big enough telescope and a long enough exposure. What's all we see here is brighter galaxies and local stars. So it's slowly getting a little bit better. quite interesting. You can see over there that that's not a point light thing, so that's probably a galaxy. So anything that isn't point like is probably a galaxy. But most of these things look like stars. So that's the eyes. NGC 4438. I'll probably never forget that now. I mean, naming of things, I mean, we have things like the Owl Nebula, which looks like an owl. There's various other nebulas that have got similar sort of, have got more names that describe them more. Let's save the image. So this was NGC 4438. Save that. Okay. Right, so that's most objects. What I wanted to finish with, if I could, was to try and find a comet. So let's go to our software again. Search for comet. Now I do know that there is a comet called C/2019 Y4 Atlas. So let's OK that. We'll go to that. Right, this comet was one that was recently thought to be going to go quite bright. But unfortunately, in the last week or so, people think it's broken up as it's got close to the sun. So although it might have been bright, it certainly isn't as bright now. So let's see what it looks like. There are always quite a lot of comets in the sky at any one time. I think the scope can see through holes there. Let's plate solve. So let's see. So it's capturing an image. There we go, so the image change. Comets, well, we all know comets move, but they're not, they move faster than the background. So stars, they don't move, we move, the Earth rotates. So stars cross the sky, well, they're always fixed. Comets move against the background. So if you take an image of, say, 2 or 3 minutes, a comet will actually move against the background stars, which can be problematic for taking photographs. Do you image the comet or do you image the stars? If you image the stars, they become points, but the comet becomes smeared a bit because it trails. If you image on the comet, then the stars become smeared and trailed. So it can be quite hard to get a good picture of comets. There are ways around that, but it's never very easy. Right, it says it's aligned. Let's go back to our imaging software. We'll stop stacking that and we'll reset. And see what pops up. If anything. It's just a stop and start. Imaging, let's try that again. It seems to have decided not to take an image this time. Oh yes, it's doing something now. See what happens. Not a lot, it would appear. Stop taking images. Let's just visit it down earlier in the evening where it it didn't seem to want to take images properly. I'll just change the exposure from 10 seconds to 5 seconds to see if that makes it do things, and the answer is no. Stop it a minute. Let's just change mode. Back to that. You think reset would actually clear the image, but it doesn't. Let's try. See what happens. Okay, well, software is always a bit. Let's just drop that software. Disconnect the device and then reconnect it and see what happens. Devices. Oops. Connect. Start up the software again. Okay. So let's go to video mode, 5 seconds. Let's see what happens now. Right, at least we have an image. Although I can't see a comment on it so far. Let's try a longer. Let's try a 10-second exposure. See if that makes any difference. Oh, there's another satellite passing us. Let's try stacking. I'm wondering if that there is the comet. I was saying this comet was supposedly going to be very bright, but it was discovered it broke up, which means it will be less bright, much less bright. Definitely you can see how less bright it is, because that's it, that is the comet there. So that's probably the head of the comet, and the tail's going in this direction. But it's, of course it's quite faint, isn't it? Comets are pernickety things. They quite often get proposed to be very bright, but never seems to work. Yeah, so that is the comet there, but it's very dim. So with that, I think we'll say goodbye. Thank you for watching, and hopefully see you next time, and hopefully next time the streaming will work better as opposed to having to record it like this. We'll find out. So bye for now.